Howdy. There has been quakes again, also here in France. People were reporting about quakes. Nouvelle-Aquitaine, ça fait un gros boom, peu tout à tremble dans une grand mais pendant plusieurs secondes. A big boom and some tremors heard or something, and it lasted for several seconds. I guess grandement prolonge précédé de boom. Everybody heard a boom. Een gros bruit sourd pendant quelques secondes. So it lasted for several seconds. My French is really bad. Less than 5 seconds. Roulement sur. I don't know what that means. But anyway, people were reporting about that. There was also quakes somewhere here. Maybe they already have gone earthquake filter 2 days. I think it was this one. There should be a Black Horse Mountain close to that. Cheval. What was it? Cheval Noir. The Black Horse Mountain. And here's the quake. 2 days ago, 1.85 kilometers in depth. And we are about 2,000 meters above the sea level, maybe even more. So the quake is actually quite shallow, 3 kilometers in depth from sea level. So I went over to Google Earth and checked out what I found in the region here, near this Cheval Noir. So that's on top of the hill, or mountain, I guess. There's a horse and a lake, which has somewhat a craterous appearance, and tetrahedrons in shallow angles. And here they are vertical. Really interesting, really nice. And that's also really nice. We have those fulgurites. You just have to imagine the lightning bolt. There are several of those still standing. And that's a really interesting picture, because I don't know if that's still a mountain or it's that in the clouds. I don't know. But anyway, that's again the horse. I wanted to show you some other things there in the region. Maybe I got to search a bit, but like here we have these structures which might have been once erupting out of the mountain. But there was a really, really interesting place. So now I found it, finally, Cheval Noir. So now you just follow that line, and then you zoom in. And here we have some really, really, really interesting geological features. which have a craterous appearance. And they are in some kind of an alignment. And we have those even here. And they are almost totally round. Let's just measure this bigger one, 15 meters or something. I would say this is really interesting that we have these kind of forms in the Alps. And there's like human activity going on there just over these structures. There's actually more down here. But I think they are really interesting. I don't know. Are these natural? I guess that these are totally natural occurrences, and there is even water bodies as well. And if we go here to the left, Grande Combe. This might be some rhyolithic lava flow or whatever. Maybe the difference of the colors here. Here it's brighter green. And it is reddish. Might indicate the difference in the minerals in the soil. Or maybe there is something coming out of the ground, some gas emissions or what have you. Hard to say. Is there any pictures of those? Yeah, this seems to be a construction site. Maybe they're digging something interesting. All right. Yeah, that's really cool. Fulgurites. A really good indicator for electric energy being involved in the creation process of these rocks. That's really nice. But I think I still wanted to show you quickly a picture I made from one of those craters, a collage. That might be from a different place. But the inserted picture is from the video, which I'm gonna share you a short amount of it. Yeah, this was said really awkwardly. But anyway.
Simple bowl-shaped craters, but also craters with a central peak. The main aim was to try and show that a similar mechanism could be used to explain all types of craters. Both Ford and Desai's work were based on creating craters on a metal surface, which is not really representative of most planetary bodies. C.J. Ransom expanded on these experiments by using materials that are found on planetary bodies, such as sandstone, barium carbonate powder, and aluminium hydrate powder. He has written a number of papers, some in conjunction with Wal Thornhill, about the results of his experiments. He was able to demonstrate an extensive range of features found with a range of plasma and sample conditions. These included crown-like features, rimless circular, and non-circular craters, crater fields, multi-ring craters, and a variety of Lichtenberg discharge patterns. Sometime later, Billy Elverton started experiments examining electrical discharges on surface formation. In particular, one aspect he focused on was what would happen to the particles in an electric field as well as a discharge. He also showed evidence of crater formation as well as demonstrating the effects that the field would have on the smaller particles and how this could be responsible for many other features, not just craters, including the carving of plains, valleys, the formation of ridges, and mountain-like structures. What both C.J. Ransom and Billy Elverton showed was that the material used as the surface made a huge difference to the types of patterns observed.
Giants of science. Check out them videos and think for yourself. I will put links below. I try to put links to the craters I just found today in the French Alps. Probably it's France. I don't know. Maybe Switzerland. I don't know. Maybe it's France, I guess. But anyway, I will leave it here. Thanks. Bye.